Hey folks, it's Prof G here. Talk about feeling a bit remiss. Since the term has started, the semester has started, we have talked about several things. Price elasticities, we've talked about supply and demand, movements along either curve, shifts in the supplier demand curve, and what causes those. A change in price is a movement along the curve. Any other factor that changes supplier demand will shift the curve. What else we've talked about? We've talked about the PPF, the production possibilities frontier. We've talked about trade. Lo and behold, as I'm sitting here tonight, I thought, I haven't gone over on video, and I don't think in class either, how to determine and calculate equilibrium for a good or service using the equation of a line. And I'm going to go ahead and do that now. So if I've already done it and I forgot, I apologize for the redundancy, but better safe than sorry, right? So let's say, let's call this, well, I'm going to go to the white here. Here's our, let's make a little graph, right? And I'm going to draw my demand curve and draw the supply curve right there. Here's supply, and demand. Now, what are these? Well, somebody say, well, that's a supply curve, that's a demand curve. That is correct. That is technically correct, yes. But without any of these labels that we're throwing on here, one could say, well, it's just, these are lines, right? These are lines with slopes, the y-intercept at some point. That's what we have. So the equation of line, as you know, is y equals mx plus b. And real quick to the side over here, let's define what equilibrium is. And that's when quantity demanded equals quantity supplied, where and that is equilibrium, E. I think it's how I've mostly denoted that in class. So we have a group of households, consumers, purchasers, that for a particular quantity that they demand, they say, sure, I will pay that amount of money for that particular good or service. Then on the other side, you have the producers, the firms, the suppliers that say, we develop this good or service, we manufacture it, we send it down the wholesale retail chain, and given everything that the cost of inputs, the labor, et cetera, so on and so forth, we feel that this is a fair price to charge. This is the price we need to charge for this product, this good or service. And those two prices are in agreement. Consumers and suppliers will shake on it and say, great, we have an equilibrium price right here, right? And that matches up with an equilibrium quantity. However, back to this equation of the line, we can't just simply draw a couple of, a blue line and a red line, intersect them and say, hey, that's equilibrium. Sometimes this is shown algebraically, not really algebraically, but more mathematically, by the slope of the line. So what do we have? We have y equals mx plus b. Here's our slope. Here's our variable. Slope. Here's our intercept. And of course, this is our f of x. So let's assume we get a couple of functions. Let's say our demand function. Demand is listed as, say, 24 minus 4p. And what do we have here? Well, here's our y-intercept. Just happens to be in kind of the wrong order. Here's our x, our variable. Here's our slope, 4 over 1, or more appropriately, negative 4 over 1. And that's how you know it's a demand function, because of the negative sign. Because also, of course, the slope of the demand curve is always negative. Let's do the supply. The supply function. In this particular one, let's go with, let's use some numbers that won't throw us off here. How about 6 plus 2p? Once again, we have our slope. It's a positive 2 over 1. We have our variable, and we have our y-intercept. So far, so good. Now, how do we determine what quantity and price is going to come out to be? That answer is right here, where quantity demand equals quantity supplied. Equals, or, equilibrium, as it were. So when you get an equation of a line, that is basically the definition of your demand function, the definition of your supply function. You set them equal to each other. Boy, there are a lot of arrows on this screen. Let me clean this up a little bit. I'm going to put you on pause for a second. I'm going to erase some of this and then get into the calculation here. Okay, so we have our equilibrium. Quantity demanded equals quantity supplied. What was our quantity demanded function? It was the equation of the line, as we've talked about. That was, this is quantity demand. Let's go. I'm going to put quantity demanded right here. 24 minus 4p. P, I think you can probably infer by now, is price. And our quantity supplied is 6 plus 2p. Okay, so far so good. And if we want equilibrium, this is where we set them equal to each other. So let's set these two equations equal to each other. Now, with a little bit of algebra, we can go ahead and let's just move this 4p over to the right side, right? So we'll just kind of cancel that out. We'll add 4p. And let's see, why don't we subtract this 6 and bring it over here. We'll add 6. Okay. So now, after all said and done, what do we have? 6p over here, and then on this side we have 24 plus 6. 24 plus 6 is 30. 30 equals 6p. So what we, wait a minute. I think I goofed up. In fact, I know I did. If for any of you watching at home, feel free to tease me in class. Well, it's late. I've had a beer, so maybe I'm not thinking so clearly. Let's back up just a sec here. There we go. And also, let me just get rid of this. Boy, that's embarrassing, huh? Hey, not all of us is perfect. Even the guy that grades your tests and your homework. So it's not 30, it's 24 minus 6, not 24 plus 6. So 24 minus 6 is 18. Wow, do I feel better about that? Okay. Let's divide through the 6 to find that our price is equal to 3. Price is equal to 3. So if we want, we could come over here and say equilibrium price to the graph. We can come over here and say equilibrium price is 3. 3. Okay. So now we need to find what the equilibrium quantity is. Well, we'll back up real quick and just rewrite those. I'm sure you can tell. At this point, what we do is we just substitute the number 3 to where we have price in either equation. And you'll know that something's gone wrong, which I almost did. You'll notice something goes wrong if after substituting 3 for price and quantity supplied, and doing the same for quantity demanded. If these answers don't come out the same, then you'll need to back up and take a look at what's going on. 24 minus 4 times 3, 6 plus 2 times 3. So we have 24 minus 12. 12. Now I'm being extra careful so I don't make the same goof up twice. 24 minus 12 equals 12, okay? And we have 6 plus 2 times 3 is 6. So you can say 6. 6 plus 6 equals 12. So they match. We're good to go. Quantity is 12. Equilibrium quantity is 12. So our equilibrium quantity here is 12. So this is how you determine equilibrium on supply and demand using the equation of a line. And typically that's, not typically, but sometimes you will be presented with as demand functions, supply functions in this type of mathematical form in terms of the equation of a line. But that's how you solve for your equilibrium price and equilibrium quantity. Hopefully this isn't redundant, but if you have any questions, certainly drop me a note in the comment section below or shoot me an email. Next week we can just touch upon this in class just to make sure we all understand. And my apologies for the latent tutorial here. Should have had this posted a while ago. Either way, hope it makes sense. If it doesn't, you know what to do. Stay warm out there. Have a great weekend, and we'll see you again soon. Cheers.